Hello everyone, welcome to this video. Today we're going to dive into an exciting machine learning project predicting the sale price of a bulldozer. Okay, predicting of a sale price of a bulldozer. Okay, in this project our main goal is to predict how much the bulldozer will sell for at auction. Based on its characteristics and historical sales data, machine learning gives us the tools to analyze post data and make informed prediction about future sales. Okay, so let's clearly define the problem. We want to answer this question. Given the features of a bulldozers and historical sales data, how accurately can we predict the features sale price? Okay, so I'm defining this problem definition. Problem definition. Okay, then we want to answer the key question. Given the features of a bulldozer and historical sales data, how accurately can we predict its future sale price? This is a classic regression problem in machine learning because our target variable, the sale price, is a continuous numeric value, not a category. Unlike classification problem, where the output is a label, here we need the model to output a specific number that closely matches the actual sale price. Solving this problem is valuable because it can help auctioneers, dealers, and buyers make smarter decisions. For example, predicting the right sale price can prevent understanding of the or overpricing bulldozer, saving money and increasing efficiency in the market. Okay. Now, predicting bulldozer is not as simple as it sounds. There are many factors that can influence the price. The age of the bulldozers. Newer machines usually sell for more. Users hours. More used machines tend to be cheaper. Machine specification like blade type, engine powers, and hydraulics, market conditions, and the auction location. Our datasets include over 50 features, and some of them have missing value or irregular in types. Handling this properly is crucial to build an accurate models. Okay, understanding this problem is in a real-world context is important. Accurate price prediction can help dealers set competitive price, buyers decide when and what to purchase, companies evaluate the reasonable value of their machinery. So this project is not just a machine learning exercise, it has practical real world application. Okay, now I will define here all of this that you can understand this problem definition. Okay. Okay, I will define this. Okay, then there are many factors that can influence the price. Okay, the age of the bulldozer. Newer machines usually sell for more. Then uses hours. More used machines tend to be cheaper. Machine specification like blade type, engine power, and hydraulics, market conditions, and the auction location. Okay, this and more. I'll see our dataset includes over 50 features, and some them have missing value or irregular entires entries. Handling these properly is crucial to build an accurate model. Okay, I will take this in normal. Okay, in the next topic, but in the next part of the video, we will take a close look at this dataset. We'll see what features are available and start preparing the for data for modeling. But for now, we have clearly defined the problem and understand what predictive bulldozer is both challenging and useful. Okay, okay, our problem definition is clear. Here, I will do this here and another. Okay, now it is clear. Introducing this dataset. Okay, welcome back. Now that we have defined the problem, let's take a look at the data we will use to predict bulldozer at sale price. The data comes from the Kaggle competition called Blue Book for Bulldozer. Blue Book for Bulldozers. It contains, you can find it here. It contains historical auction data for bulldozers, including their specification, users, and sale price. Okay, I am going to here. Okay, data. So the dataset is divided into three main files. Okay, train.csv. This contains data up to int of 2011. Value.csv is validation set. This contains data from January to April 2012. We use this to validate our model while developing it. Trace.csv the contains data from May to November 2012, and it is used to evaluate the final model. The data is not released until the the final stage of the competition. Okay, going to the come back to our notebook. First, let's load the training and validation sets in Python. Validation sets into Python using pandas. Here, how we do it. So import. Sorry, here I need to set up the kernel. Import numpy as np. Import pandas as pd. Import matplotlib dot pyplot as plt. Okay. Then load training and validation data. tf is equal to pd dot read csv. Okay, I need to here validation teletrain and validation csv. Then I need to copy file path. Okay, this. Then law memory is equal to false. Okay, check the structure of the data. df.info. Okay, let's hit the enter. And what is the problem included? Okay, here I need to r. Okay, now it's already defined this. Here Low memory falls helps avoid memory memory uses when reading large CSV file. The info function gives us an overview of the dataset, including the number of rows and columns and data types. Okay, this dataset contains over 400,000 entries and and 53 features. Some case features included sales ID. I can see here, sales ID, unique identifier for each sale, then sale price, the target variable we want to predict, then machine ID and model ID. Identify each bulldozer year made, the year of the bulldozer manufactured, machine for current meter, and etc. and etc. Many of these features are numeric, but most are categorical or having missing values. That we will need to handle this carefully before building our model. Okay, since for after this for it's important to know which features have missing value because missing data can affect model performance. We can check the uses using check this using just check this using df dot isna dot sum. So here I am seeing this for for examples here. Machine for current user have a lots of machine values. Okay, like price, sale price, and year made. The exact sales just decide which features to keep, fill, or drop. Finally, let's take a look at the column names and data sets. Okay, the list of all 53 columns, which include machine characteristics, action details, and equipment features. Knowing the upfront is crucial for exploring, calculating, and preparing the data for our model. So far, we have loaded the dataset, explored its structure, and identified missing values. In next part, we'll dive deeper into exploring data analysis and cleaning so we can prepare the model for machine learning. Now that we have loaded the data and explored its structure, the next step is to understand how we will evaluate our model and the features we have to work with. This step is crucial because knowing the evaluation metric and features guides how we prepare our model and build an accurate models. Okay, this evaluation matrix used in this project is RMSL. Okay, I'm going here. Evaluation. The evaluation metric used in this project is called RMSLE or root mean square error or root mean square log error. Okay, but what does this mean? Essentially, RMSLE measures the difference between the actual sale price and the predicted sale price after applying logarithm transformation. Okay, it's why RMSL is useful. It reduces the impact of very large value in the dataset. Bulldozer sale price can vary a lot, and using RMSL prevents extremely high price for dominating the error. It penalizes underestimates more than overestimates in a logarithmic way, which is often preferable for principal problems. Our goal is minimize RMSL, meaning we want our prediction to be all close as possible as the actual field price. You can read more about the Kaggle competition page. Okay, next let's look at the features in the dataset. We have over 50 features which describe various aspects of each bulldozers. Some important characters of the features included identifiers, price of action info, machine characteristics, attachments of statistics. Some features are numeric like sale price and year made, well many are categories like product size or transmission. It's also important to note that some features have missing value like machine hour currently meter, then hydraulics flow, etc. etc. We can cleaning stage. To better understand its features, Kaggle provides the data dictionary which explains that each column represents. You can view it here and the view it here. Okay, you can view it here. The dictionary is very helpful because some features names are not immediately clear, like 5s model and 5 secondary days. By referring to the dictionary, we can understand what each features means and decide whether it's useful for our model. Okay.